it's so close to my personal life. I worked for a large EPC, Continental Energy Solutions, that was very responsible for this project that you're going to hear all about at Magid Glove Safety. We have David Braun, who is the Vice President of Sales and Marketing for Intelligent Generation, a well-kept secret here in the Midwest until just recently. So if you're not familiar with Intelligent Generation, you want to know Intelligent Generation for software as a service in PJM for battery storage. And we have Harvey Cohen, who's the Vice President of Magid Glove Safety, a large manufacturer here in the Chicago area with one heck of a ginormous roof that is now sporting 10,500 solar panels. So with that, I'll let you gentlemen take it.
Great, thank you, Tim. And just to be sure, Harvey is president of Magid Glove, so.
I got promoted.
A long time ago. So, as Tim was saying, I'm David Braun with Intelligent Generation. Harvey is one of our early customers and really a pioneer in doing behind-the-meter solar and storage. And so, here today to tell some stories about the project that we all worked with him on at their plant in Romeoville. Intelligent Generation is really, I call it an energy technology company. We're software as a service, but we're also a member of the ISO as a market participant of the ISO. So I'll explain what all that means in a second. But the software side, we do battery optimization and controls and dispatch for behind-the-meter batteries at commercial and industrial customers. So batteries can do a lot of things. I'll talk about that in a second. But they need something to tell them what to do, otherwise they just sit there and do nothing. So we're the tell it what to do side of that. And the company's been around since 2009, founded by Jay Marhofer, who wrote a book about the value stack of batteries back in the mid-2000s, before anyone even thought of these things, and then formed a company. And since 2009, they were developing the software. I joined just a year and a half ago, so I can't take credit for all the great work that's been done up to this time by some of the people here in the room. But we've also been dispatching these batteries since 2014 from behind the meter or at commercial account sites, which is really early. I was on the utility scale side, and utility scale was just getting kicked off back at that time. So it's really innovative. But we've got algorithms running in the cloud, looking at the value stack of all the things the batteries can do, and then deciding in real time what that battery should do, and sending out signals to the battery to say charge or discharge. Some of those signals are coming from the grid. And then, as a member of the grid, we can bid the battery into it. So we talk about, kind of our mantra is earn, save, protect. So we help customers save money on their electric bills by reducing those electric bills. I'll talk about how we do that in a minute. And then we help them earn money by dispatching that battery to the grid and actually delivering services to the grid and getting paid for it. And then it's also there to protect what? Protect the operation, keep the lights on, keep manufacturing going as backup power, and then also protect the environment, because batteries can reduce CO2. It's not direct like you see with solar, right? That's easy to think about. We're generating clean kilowatt hours and not using fossil fuels to do that. But we displace coal, we displace gas units, we displace even jet fuel and oil units in some cases that are running at the peak hours, these peaker plants, or are running to do other services for the grid. The batteries can provide faster, the batteries can provide better, and so now regulations allow us to do this. Let's talk about the value stack for a minute. So batteries can provide energy and power to the grid instantaneously, on demand. So it pairs well with solar. Solar and wind, being intermittent resources, rely on the weather phenomenon that basically runs them, right? So solar doesn't generate power unless the sun's shining, wind doesn't generate power unless the wind is blowing. And the grid needs really three things to operate at a base level. It needs those kilowatt hours to have the energy to supply our motors and our heating elements and computers and everything else, lighting. But it also needs power, and what that means is having the dispatch to be able to follow that load and be available when the dispatchers say, hey, we need another 100 megawatts right now. They can push a button and know that's going to be there. They don't know that with solar, they don't know that with wind, because the resource has to be available. So batteries can provide that power side, which is measured in kW, right, on your bills, kilowatts. I won't get into all the details on that, but that's the kilowatt side of the billing, making sure that peak load is there, all the way up to satisfying the peak on a hot summer day, and that's where we're replacing some of the fossil units. So solar is great at generating kilowatt hours, but not generating power, and that's where the batteries come into play. So what we can look at in the stack, batteries providing kilowatt hours to the grid when needed, and that could be things like energy arbitrage, right? Charging when the price is low, discharging when it's high, or storing excess solar that is not needed by the grid during peak times, and maybe just dispersing it during the shoulder hours. So that's something we look at. We look at demand. Commercial customers have to pay a demand charge. That's a monthly bill to ComEd or whatever utility you're behind to pay for the wires. And that's a hard thing for us to do, because usually that's measured every half hour. They take the peak of those half hours for the month. So we can, with a battery, maybe displace a spiky peak, but not a more typical hill type of a peak that you see over the course of a day. But capacity and transmission, which are priced in PJM and MISO to some extent, just on a few hours a year. So in PJM, you get billed as a commercial customer based on what you're using in the 5 peak hours of the year. So we can forecast when that's going to happen, discharge the batteries, and reduce up to 25% of the customer's bill right off the bat. So that takes about maybe 20 times a year to make sure we hit those 5. We've got 345 other days a year when that battery needs to do something, and that's where batteries can provide that third element that the grid needs, which is all those balancing services to keep the grid functioning properly, and that's things like frequency regulation and reserves and voltage control. And there are tariffs in PJM to pay generators to provide that, and batteries can do that now. And so that's where we come in, looking at that value and deciding which of those ancillaries can we provide in any given minute. That's a market now in PJM. We can bid into those markets and then get selected and paid to operate in those markets. And then as the market member, we're getting paid, and then we share a payment to our customers back on a monthly basis. It's a shared savings or shared earnings model that we have. So our customers actually get paid by us. We don't send them a bill, which is always a nice place to be. So then it's that value stack that we're looking at all the time. And then if that customer also says, hey, I need some left in the tank all the time in case the power goes out, to keep my operations going, maybe at least until they can get a standby generator up. And typically, outages are pretty short anyway. So we can provide that bridge, provide that protection for their facilities to keep running. So it's that earn, save, protect. Right now, let's shift on that operating side. Let's shift a little bit just for a minute to talk about the regulations and the state law that gives extra value right now, especially in Illinois. Illinois is, if you listen to some of these legal and regulatory sessions over the past 2 days, you've heard things like CEJA, the Clean and Equitable Jobs Act of 2022. That pays a rebate in Illinois of $250 per kilowatt hour of battery, in addition to $250 per kilowatt of solar, as a rebate to help finance these projects. And that's another part of the value that helps finance these projects. So from the standpoint of regulatory incentives right now, or legislative incentives, we have the investment tax credit on the federal level, and even some batteries qualify potentially for domestic content, so we're getting up in the 40% range, even 50% range if you're in an energy community. And then it's accelerated depreciation and other benefits like that, and then the state rebates on top of that. We're seeing right now 70 to 80, sometimes even higher percentages of those project capex costs for batteries and solar getting paid for in year one. So your payback is accelerated by that much. And then the savings that we can bring operating the battery and through all these value stack propositions, we're seeing on a battery only probably 2 to 3 year payback on that capital investment in the project. with solar anywhere from 2 to 4 as a typical payback period. So really a great opportunity right now. And if you didn't catch this back on April 15th, kind of to celebrate a big project, one that we participated in also, the governor and the CEO of ComEd and some other politicians came out to GMW Electric in Bolingbrook and presented a $2.6 million check to the president of GMW, John Mueller, for the microgrid that he built there with solar, battery, a flywheel, and backup diesel generation. But because of the CEJA rebates in Illinois, he got a $2.6 million check. It was notable because that's the largest check cut so far under CEJA. So that's proof that this is real. This money is there, and these projects are a great investment right now with the support of the state. So I'd like to turn it over now to Harvey. I've talked enough, and let Harvey talk about his great project and some of the benefits that he's had. So I'll let you take it away, Harvey.
All right, thank you. I'm president of Magid Glove Safety. It's a family-owned business. We started in 1946. We moved to Romeoville about 10 years ago, and at that time we decided to look into solar. And those of you that have been around 10 years ago doing these projects, you'll know that, as the kids say, solar in Illinois was not a thing. So we had a hard time trying to find out information, and I knew nothing about solar other than it was a nice science experiment. So we finally got into a developer, Convergence Energy, and they're very smart and very knowledgeable, and they showed us how the solar can be a financial boon besides backing up when the grid is down. And we also, part of our, I call it the team, we were using Continental, too many C's, Continental Electric for doing some of our internal projects, and they had done some solar, so we opted to use them for their solar project, and we have a 3.5 megawatt solar array on the roof of our building. It's a 700,000 square foot building, and it's 10,500 panels. It's one of the largest solar arrays in the Midwest, and probably one of the 10 biggest rooftops solar arrays in the country. And while we were putting in the solar panels, Convergence Energy, the developer, came to us and said, you ought to really look into batteries, and there's a number of reasons. Well, first of all, when the grid goes down, you have to shut your solar panels off by law. And so, because one of the reasons we put in the solar was to keep our business going, because our customers depend on us to give them product sometimes the same day or the next day. So we can't be down when the grid is down. And so when we realized that to bring the solar panels back online, you needed to have batteries, and then the incentives that David was mentioning, capacity savings, transmission savings, the financial benefits from doing frequency regulation, it seemed a no-brainer. And so we ordered batteries. We have 2 1 megawatt Tesla batteries at our facilities that back up the arrays, and they were put in 2 years ago. One is up and running now doing frequency regulation, and the other one is in the process of doing the interconnection right now with ComEd. And the project was scheduled to pay back in about 4 years. As it turned out, it paid back in 3.8. So, like I said, the 3 really people you need for your team are the developers, the people that put in the nuts and bolts and the wiring is Continental, and we do the battery frequency regulation and the savings with intelligence generation. And I think they're one of the finest 3 sets of people you can have to do these projects. And by the way, these are complicated projects. It's not just throwing a few panels down the roof of your building. There's a lot that goes on. And
Can you talk about some of the hurdles that you met along the way?
well, here's the thing. The developers and the electrician, Continental, they knew about the wiring and what you have to do, and it's very technical. But I would say that the three biggest hurdles that we encountered along the way, including putting in the batteries, was 1, ComEd, 2, ComEd, and 3, ComEd. So they talk about that they're all about the green convergence of the world we're coming to, but they're not very cooperative, and you really have to kind of fight them along the way. But we're getting there. So I would say that's where we are right now, but I would recommend solar and batteries to whoever wants to do them. And I'm here to help people along the way if they have questions and they want to come out and kick the tires. Our facility is open to anybody who wants to come by, and if you guys want to bring potential customers, we're open to that too. So if anybody has any questions or.
Let me ask you this before we go to the audience too. The rebates that are available and some of the tax savings, we're able to capture that.
Oh, absolutely. At the time we put in the solar, there was a 30% ITC, and now it's up to 40% because we happen to be in an economic zone. And we're actually looking at putting in another project of some additional panels because our needs for power have grown from the first time we were out there 10 years ago to where we are now. And the incentives that are there, I mean, it's paid for, I would think, at least half of the cost of putting in these projects. So they're real, and it's real money.
How do employees feel about having solar and batteries at your site?
Well, the employees are great, but something else that kind of happened along the way, when our customers found out that we had put in solar, it was like, wow, you guys are terrific. And so we have these big white hats we're wearing because we've gone green, and people realize that people that are going green and saving the world are worth doing business with. So I mean, recycling is fine, but doing green is another place where you can really have a benefit with your customers. So that turned out to be a great thing.
Good, yeah, good benefits. Do we have questions from the audience? Yeah, in front of you.
Harvey, how did you decide your solar size? I assume you just did it the whole roof?
No, actually we did it's about 75%, but the new project we're working on right now will fill the roof with panels.
And I always thought the batteries were about the same size as the solar, but if I heard you right, you said you're about 3.5 meg of solar and 2 meg of battery.
Correct.
You can explain how you made that decision?
Yeah, well, the solar, we decided that we were gonna shoot for 90% of what our energy needs were back when we moved to Romeoville. And we've grown since then, so actually that's the reason for the new project. And as far as the battery size, you need a certain size batteries to what they call turn the solar panels back on and become a microgrid. Because in order, when the grid goes down, your panels go down, the batteries then show power to the computers that run the solar, and they turn back on. You're disconnected from the grid, and you don't quite need 2 megawatts of battery for the 3.5 megawatts of solar, but because of the incentives with the frequency regulation and the amount of backup that we wanted for our facility. So right now the batteries give us a 2-hour window of power in case it's winter and the snow is covering the solar panels. So we have a minimum of 2 hours, but with the batteries plus the solar, when there's not inclement weather, we technically can keep on going 24/7.
And we've got proprietary software that we've developed to help size the battery, and both from the megawatt size and the megawatt hours, right? Because batteries are measured both by their inverter capacity as well as the amount of energy that they can hold. So that's the kW and the kilowatt hour measure. But so IG along with Continental and Convergence all helped evaluate their loads and evaluate the size of the solar and understand, figure out what the right size for the batteries. Harvey was also limited at the time because that array was built during the FEJA Act. And so that was limited to 2 megawatts at the time. Harvey was able to get 4 because he had 2 tax IDs, which ComEd's since closed that loophole. But now that Siege has raised that to 5, he's able to now add some more megawatts now that his load's also grown. So, do you have a question over there?
Yeah, 2 questions. Harvey, what's your peak demand? What's your in a manufacturing plant like yourself? What's your highest KW? Your peak?
I don't know the exact number, but what happened is we don't really have any peak because everything is kind of pretty, stable. We don't have like peak loads that go on and off because it's a warehouse operation. We have a small manufacturing amount, but there's no peaks to say. But
You're pretty steady, because some manufacturing plants, right, if you dive into manufacturing plants have, they turn all the machines on, their KW is way up.
Way up, yeah.
Facilities, we work with a lot of grain facilities and that sort of thing.
yeah, we don't really have that issue. But the one thing that I was, to your question is, you really have to have the developers, because they look at your electric bills and they can, because every project really stands by itself, and you have to figure out what you need. That's how we came up with the 10,500 panels and the 2 megawatts of battery, based on our load and our power demands.
Gentlemen, thank you.
I think you just started to answer it. So your battery capacity at 2 megawatts is really mainly triggered on your load relative to your array size, meaning you didn't really have a lot of extra generation capacity to use for storage for arbitrage. Is that why you stopped at 2 megawatts of battery?
The 2 hours was because how long we felt we needed in case of that, where there's no solar available, like the snow is covering panels or it's night. So we wanted to have a minimum of 2 hours of battery to keep the facility going for short grid outages. If there was a horrendous grid outage where you were out for days, I mean, there becomes a financial question. How big a battery do you want to put in? And we don't have any generation equipment other than the solar to back up our facility. So like I said, it depends on what's going on in your facility and how much money you want to spend on solar, batteries, or generation equipment.
So are you selling with your system? Are you able to sell much back into the grid?
Right. Well, we do frequency regulation.
Okay.
Yeah.
But with the 3.5 meg, I think, Mark, correct me if I'm wrong, I think their load's probably just under 2 megawatts total.
Okay.
Do you know?
The maximum load?
Yeah, their maximum.
It's less than 1.
It's less than 1. Okay, so they do, when they're generating 3.5 in a peak day, sunny day, they're going to be net exporting back solar generated energy to the grid. The operation that IG is directing with the battery is really independent of that, because we can charge and discharge to the grid. We don't need to be solely charging from the battery or solely discharging into the load. So we can, oftentimes our load is enough that with 1 of the megawatts we can be discharging back into the load, but we can also with net metering be discharging back to ComEd as well, and in and out with that.
Yeah, like on the weekends, obviously our plants shut down, and so all the energy the solar's producing is going back to the grid as part of the net energy in Illinois, where you get a credit for it. And an interesting thing that happened with CEJA when it came out, the new law, that our capacity not only went to 0 and our transmission charges went to 0, but because we're have solar and batteries, we actually are making money on the capacity and making money on transmission. We have a negative charge, in other words, a credit on our electric bill from ComEd because we don't use 100%. We're below 100% of our needs. So the capacity is actually a credit on our bill, and transmission is a credit on our bill because we've gone to 0 because of the having solar and the batteries over the years. So that was like icing on the cake, actually.
Yeah. Over here.
Yeah, if you can feel comfortable talking about it, that's not an inexpensive venture, right? Solar, battery.
Yeah, the investment.
Yeah. So our.
How did you finance it?
We're a very profitable company.
It's nice to get the tax credits as well.
Right, but the solar, the 10,500 panels was around $6 million, and the battery part was about $4 million, roughly. So the whole thing was like a $10 million project in total, but well worth it.
Yeah, and
I
you-
would do it again.
You didn't have to finance any of that, that was.
No, we didn't, no.
Yes, and back.
So I work for a solar developer out of Indiana. We're putting together a request for proposal for a muni utility right now, for a 3 megawatt system. Now, they came back and said the Friday before our last meeting, their peak demand was between 7 and 8 PM in the evening. As a result, they came back with a request for a 3 megawatt array and 7.5 megawatt hours of storage. Obviously, the cost of that is tremendous. Can you talk
Yep.
about the future battery demand and cost?
And what we've seen in the past 4 years is costs coming down and then costs going way up because lithium supply chain issues. And over the past 6 months to 8 months probably, we've seen declining lithium prices, and that's starting to reflect over the past few months in declining finished product, full battery system costs. So we're seeing those improvements. The use case is very important and something that really needs to be understood well when sizing that battery. Yeah, some of these muni projects, I'm not sure they fully understand the use case that they're after, and the best way to size that, both from a megawatt and a megawatt hour standpoint, to maximize their returns. But munis, from a ISO perspective, look a lot like an industrial customer to the distribution utility, right? It's a meter. That battery is now behind the meter. There are certain charges that those munis and co-ops face that look just like the charges that Harvey faces as an industrial customer, the capacity charges, the transmission charges, having to pay for ancillaries. And so batteries can provide that also and do it from what looks like behind the meter to the ISO. So those are all things that can become value streams to those munis. Some of them get very complicated with the generation contracts and their point-to-point transmission contracts from that generation. So that may be why they ended up with such a long duration on that case. But right now we can do what our value proposition case in PJM with as short as really a 2-hour battery. We go to 4 typically in Illinois because of that. CJA rebate basically pays for the extra 2 hours, and then you get a longer life on that battery, lifespan of the battery, and much higher likelihood that we're going to nail that 5CP event consistently with more duration to hit it. But yeah, I'd love to talk to you about that battery in Indiana. It sounds interesting.
With that much storage, should I go back to my muni utility and tell them they're stupid?
Love to look at the value case before I say that, but
Getting paid to put it in though? I mean.
yeah, if you get paid to put it in, why not? Hate to be the ratepayer there. Other questions? Anything else we can answer? No?
I
Yes.
have a couple questions just about on the roof array itself. You said one of the largest in the country. Did you have problems with Bolingbrook in getting approvals for that?
No.
Did you build the building?
It was Romeo Bill.
It was
Or Romeo,
Romeo.
I'm sorry. Did you build the building to handle that initially, or was it a retro?
No, all right,
existing?
the building was originally owned by Sharp Electronics, and they moved out, like I said, about 10 years ago, because nobody was fixing microwaves and cell phones. You just throw them away and buy a new one. So they didn't need the building as a repair facility. They had over 1,000 people there fixing all these microwaves and phones and whatever. So the building was an as-is, and when we moved out there, it turned out that the roof on the building was over 20 years old, and it was one of these rubber roofs that are held down with the rocks they call ballast. And so we needed to put a new roof on, and while we were looking at the solar, so we opted for a heavy-duty roof, because once you put on the solar panels, you obviously don't want to start taking them off to repair the roof. So we put on a new TPO rubber. It's not TPO rubber, it's a different membrane, And with all the rocks were actually vacuumed off. We took off 7 million pounds of rocks. So there was no problem putting on the solar panels, and our array is actually what they call a ballasted array. It's held down with cement blocks. So there's no penetrations in the roof at all, which keeps the warranty for the roof intact. So it just how it was, you know, it worked out right for the kind of building we had. It was not an issue with weight because, like I said, we took off all these rocks.
Did you have any of the permitting issues with?
No, in
those?
fact, it was funny because I went to see the mayor of Romeoville, and I said, you know, I just want to tell you, we're putting this, you know, largest solar panel array in the Midwest on the roof. He went crazy. He was so excited that he waived the building permit fees for to do the array. And he then, a year after we put the array on, he convened a seminar at our facility and brought in mayors and building people from neighboring communities to brag about how Romeoville is, you know, forward thinking in this green energy. So, you know, there was great cooperation from Romeoville. I think most of the buildings, I mean, mayors and buildings, municipalities are for something like this, because there's community projects that, you know, they're incorporating. So it's a big win, I think, for everybody. I don't think there's any holdback.
Yeah, and from Harvey's roof, you can see the smokestacks of the former ComEd Will County Power Station that's now closed and shut down, which is why Romeoville is an energy community. So this is kind of the ideal situation where we're taking coal out and replacing it with batteries and solar right in that same community. So it's kind of exactly what they're looking for. Yes, last question.
So when you go on batteries, are you at full power or is it like a traditional backup generator or whatever?
No, it's at full power. Full power, yeah. The batteries give us full power, and if we have the solar, like I said, we just keep on running. And it happens instantaneously. You don't even know it's happening. I mean, there may be a light flicker for a second, but because it's all interconnected all at the same time, you don't even know it happens.
Well, great. You've been a great audience. Thank you very much for listening to us.